Hello and welcome back to the port forwarding demo. In this demo, we will learn how to configure port forwarding sessions with the OCI Bastion service. As we all know, Manage SSH session is used when we have Linux-based instance with an Open SSH server installed. Additionally, the instance must have Oracle Cloud Agent with the Bastion plugin enabled. But what if the target resource has a Windows operating system or the host does not have Oracle Cloud Agent installed? In this case, we can use port forwarding, also known as SSH tunneling. It allows traffic from a local port to the destination port on the target resource by supporting protocols like RDP, Oracle Net Service, MySQL, and most of the TCP protocols that supports SSH tunneling. So for this demo, we will take a use case of Windows machine and connect to RDP port from a local terminal. As you can see, we have a Windows machine in a private subnet and our OCI Bastion service is in another private subnet, and we need to access it from a local terminal. So the steps for deploying this use case will be: first, create a VCN and private subnets, then add rule in security list that allows traffic from the Bastion subnet to the VM private subnet on a specific port like RDP on port 3389. Next, configure your service gateway, add a route rule, and provision a Windows machine in a private subnet. Next, create Bastion, and then create a port forwarding session for the Windows RDP connection. Finally, we will test the connection over the local terminal. So let's go to the OCI console and deploy this use case. First, we will look at the required permissions for this demo. The user must have permission to manage Bastion, Virtual Cloud Network, and Instance family. And I have limited all permissions to the Bastion demo compartment where we will create all our resources. In the Manage SSH session demo, we created a VCN and 2 private subnets. And now for this demo, we only need to update the security list to allow RDP traffic from the Bastion private subnet to VM subnet. For that, I will create a new security list called security list for VM private subnet and add an ingress rule from Bastion subnet, that is 10.0.2.0 for TCP protocol from any source port to destination port number of RDP, that is 3389. We will also add an egress rule that allows all protocols from any source to any destination. We will now associate this security list with private VM subnet. Go to subnets, add security list, and then select security list for private VM subnet and remove the default list for this subnet. So the default security list now allows SSH to the Bastion subnet, while the new security list allows traffic from the Bastion subnet to the private VM subnet for RDP protocol. We have already created the service gateway and added route rules for it. For this demo, I have already provisioned a Windows machine in a private subnet. Now our task is to get a Bastion session for connecting to this Windows machine. For that, we go to Bastion service in Identity and Security. Here, we will use the Bastion we already created for the previous demo. We will now create a new session. This time the session type will be port forwarding. We will keep the default name, select the target using the instance name. Here I will select our Windows machine, then enter the RDP port 3389, and next we need to provide an SSH key. I will generate and download the private key that we will use in provided SSH command. You can then set the duration using the advanced option. For example, if you want this session to be active only for 1 hour, set the duration and click Create Session, and the session will be activated in a few seconds. After session is active, copy the SSH command and then edit the command to include the private key. I will be connecting from my local machine using Microsoft Remote Desktop, so the local port will also be 3389. Now I go to the terminal and run the command. You can see it is in running mode. That means SSH tunnel has been created. Now keep this terminal open and go to Microsoft Remote Desktop application. Add and enter the host name 127.0.0.1 and 3389. Click Add. Double click to connect and you will see that the connection has been established. You will need to enter your username and password to access this machine, and you can get them from the console. So I hope you now know how to set up a port forwarding session for an RDP port on a Windows machine. You can also connect to an autonomous database, MySQL database systems, or even SSH server on a Linux compute instance if an Oracle Cloud Agent is not installed. So I hope you found this demo useful. Thanks for your time. Hello and welcome to this lesson on the OCI network firewall. In this lesson, we will explore OCI network firewall, which is a cloud-native next-generation managed firewall service to address the challenges of today's advanced network infrastructure. So let's get started by understanding why we need a network firewall. Suppose we have our web applications hosted in OCI, and you want to allow access to them over the internet. However, giving open access to web applications can lead to several security issues. So here we can deploy a firewall as a barrier between the internet and the web application servers. Firewalls can help protect your network from cyber threats such as malware, viruses, and worms. These malicious programs can exploit the weaknesses in your systems to gain unauthorized access to your network. You can configure it to allow only specific traffic to reach your web application so that you have better access control. Again, we can use firewalls to segment your network into different zones. This can help to isolate your web application from other parts of your network, such as your internal network or your database subnet. By using firewall, we can perform application layer filtering. This type of filtering can be used to block specific applications or protocols from accessing your network. For example, you can use application layer filtering to block social media applications or peer-to-peer file sharing applications. Also, content filtering firewalls can be used to block specific types of content entering or leaving your network. For example, you could use content filtering to block websites that contain malware or phishing attacks. So basically, now we know why we need a firewall. Next, we'll look at the features of the OCI network firewall to see how it can help us secure our network more effectively. OCI network firewall simplifies security by providing a cloud-native approach to network protection. With a simple interface and seamless integration into OCI, managing network security becomes straightforward and efficient. It is built with high availability and on-demand scalability. Whether you have fluctuations in traffic or want to scale your resources, OCI network firewall adapts dynamically to meet your security needs without compromising performance. With machine learning powered capabilities, OCI network firewall goes beyond traditional rule-based approaches. It continuously learns from network patterns and enables proactive threat detection and adaptive security measures to keep your network safe from evolving threats. Next, with advanced threat protection, OCI network firewall provides a best-in-class threat engine that automatically supports in the detection of known malware, spyware, and command and control attacks. It has an integrated intrusion detection and prevention solution based on Palo Alto Networks threat analysis engine. Additionally, Unit 42, a dedicated security research team, continuously identifies new threat signatures and detection mechanisms that makes firewall more powerful. It allows you to inspect both inbound and outbound HTTP and HTTPS traffic by filtering URLs and fully qualified domain names. This granular level of inspection ensures that each data packet passing through your network is carefully inspected, allowing you to effectively identify and address potential security threats. You can block or allow access to specific websites and domains depending on your organization's security policies. It also offers the capability to apply filters for inspecting both encrypted and unencrypted traffic. It ensures that no threat goes unnoticed, allowing for effective detection and mitigation of potential security risks across all types of network traffic. Then it also integrates with logging and analytics service. So the network firewall helps you monitor health and performance of your firewall policies, and you can send notifications to specific resources or about the resources when the metrics are met. It supports two types of logs. First, traffic logs, which provides information on the traffic flow, and the threat logs provides details about the threats identified as well as the countermeasures that got triggered based on the rules we had configured. These logs help you understand what's going on and help you conduct a thorough review of the logging activity and analyze any specific pattern. Like for example, you can analyze actions, rules that were applied, and other parameters such as source and destination in provided logs. Next, we will look at the deployment options. You can deploy the firewall in several ways depending on your use case. The most common deployment models are centralized and distributed. Both of these models provide the flexibility to secure traffic flow even in the most complex routing scenarios. In the centralized deployment model, you have a network firewall instance that is deployed in a central hub as shown here. And it is connected to your Spoke VCN that hosts all your applications through a DRG. This central firewall can inspect all the traffic that is sent to your Spoke VCNs. And in the distributed deployment model, you deploy a dedicated network firewall instance per VCN that can only inspect traffic specific to that VCN. This helps to improve threat detection, reduce network load, and increase scalability. You can also use a combination of these two models to increase flexibility in your architecture. Now we know the features and capabilities of the OCI network firewall. Next, we'll look at how to set up or deploy the OCI network firewall. First, plan your deployment model that will define network or traffic flow. Then create a policy that includes all the rules that control how the firewall inspects, allows, and denies network traffic. Once the policy is completed, you create a network firewall instance and attach the policy to it. So using this three-step process, we can easily deploy our network firewall and protect the resources and complete network perimeter. So to wrap up, in this lesson, we first understood why we need firewalls, and then how OCI Network Firewall offers a powerful and easy to use solution for securing your cloud environment. It goes beyond traditional firewalls with features such as machine learning based threat detection, advanced threat protection, and the ability to inspect encrypted traffic. Whether you select a centralized or distributed deployment model, OCI Network Firewall gives the flexibility and scalability you need to secure your network. And in the following lesson, we will learn about the components of network firewall policies and how to configure them to add rules to our network firewall. So thanks for your time, and I will see you in the next lesson. Hello and welcome to this lesson to discuss the most common use cases for OCI Network Firewall. The first use case is to secure your network perimeter, which allows you to protect your OCI workloads from the threats coming in from the internet until you have time to patch or update any vulnerable system. As you can see, the network firewall in VCN can be configured with either an internet gateway or a NAT gateway for internet access. And in this example, there is a simple security rule that only allows RDP traffic from the client to your servers within VCN, and all other traffic will be denied. You can define the rule by specifying the source and destination IP addresses, port numbers, protocols, and actions. then the firewall allows you to combine rules in any combinations of whitelist, blacklist or graylist for greater flexibility and for achieving your compliance objective. Next, the network firewall also includes an intrusion detection and prevention engine, which is powered by Palo Alto's advanced threat prevention capability and supported by their world-class Unit 42 research team. This signature-based threat analysis engine identifies and prevents known exploits, malicious URL, spywares, and command and control attacks. In this example here, suppose we have a malicious e-commerce website hosted on the internet that can infect clients that connect to it. However, if you have implemented a firewall with an intrusion prevention policy that will check for malware and other threats. As a result, if a threat is detected, it will not be able to reach or infect your client. In addition, the firewall also generates a threat log, which includes a detailed record of events as well as threat information for future analysis. In our third use case, we will talk about access to Oracle Service Network. So by using the network firewall, you can write rules that configure a service gateway to inspect the traffic based on specific URLs and grant access only if no threats are detected. As you can see here, the service gateway is deployed to provide you private access to the service network. But mostly, the service gateway is configured to access all services. But over here, you can deploy a network firewall enforcing a security access policy. And in this case, the traffic assigned to streaming service endpoint is only allowed, and any other traffic to other Oracle Service Network is blocked. In addition, network firewall can help you protect against data exfiltration by limiting outbound traffic to only trusted networks or applications. For example, you can set a rule to allow only one or two servers in your VCN to connect trusted canonical sites on the internet for image updates, while blocking all other traffic from those servers to the internet. Next, in our last use case, you can use the network firewall to implement zero trust architecture and create different trust domains within your VCN. In this example, network firewall creates zero trust segmentation for 3-tier application, which includes website, application, and our database. You can configure the network firewall policy to allow communication between website and application and from application to database. However, you can block any direct communication from your website to the database. You can also use the firewall to enforce policies that limit user access based on their roles. For example, you can set rules so that only authorized database administrator can perform SQL transactions. So to wrap up, OCI Network Firewall secures your cloud environment with advanced features such as threat detection and encrypted traffic inspection. It offers flexible deployment models and granular control over network traffic. Whether you need to secure your network perimeter, control access to Oracle services, or implement zero trust architecture, OCI Network Firewall provides a powerful and easy to use solution. Hello and welcome back to the lesson on OCI Network Firewall Policies. In this lesson, we will look at how Network Firewall Policy manage network traffic. We'll go over the different types of rules, how to evaluate them, and the components of firewall policy we use to create rules. So let's get started and see how network firewall policies can help you set up rules. Network firewall policies act like a control center, defining how traffic flows through the network firewall. These policies function like a detailed set of instructions for the firewall. We call them rules. They define criteria such as source and destination, IP addresses, port numbers, and protocols to determine whether traffic should be allowed, denied, or inspected. In the network firewall policy, we define two rules: decryption rule and security rule. Decryption rules allow the firewall to inspect traffic encrypted over secure channels such as SSL or TLS. To achieve this, the firewall acts as a man in the middle, allowing the implementation of two decryption methods, SSL forward proxy and SSL inbound inspection. And security rules control network access based on specific criteria to ensure only authorized traffic enters your network. Now we will look at the workflow to see how these rules are applied on incoming packets. First, it evaluates the decryption rules in priority order. When a decryption rule matches the packet information, the firewall will decrypt the packet using the decryption profile and the specified rule action. When a rule action is applied, the firewall does not evaluate any additional decryption rules. The packet is then forwarded for security rule evaluation. And if the packet information does not match any decryption rules, the firewall will not decrypt it and packet is sent for security rule evaluation. When a security rule matches the packet information, the firewall performs the specified rule action and no other security rules are evaluated for that particular packet. If the packet information does not match any security rules, the firewall will drop it. Now, as you've seen, two key sets of rules work together. Decryption rule that handles encrypted traffic and security rules control access based on specific criteria. Now we move ahead and take a look at how to create these rules. Network firewall policy simplifies complex process by using building blocks for rule creation, such as list, mapped secrets, and decryption profiles. We first create a list with the required criteria that allows you to define applications, services, or URLs to be used as rule matching criteria. Then if we need to decrypt the encrypted packet, we create map secrets and decryption profiles. Then we create rules using both blocks, set our matching conditions, and finally attach the policy to the network firewall. The important point here is that the policies associated with one or more firewalls cannot be deleted. If you want to delete the policy, first associate the firewall with a different policy and then delete the original policy. And also, you cannot edit a policy that is associated with a firewall. To change or update the firewall policy, you need to clone it and edit the policy. Next, for setting up rules, our first step is to create lists, which serve as fundamental building blocks, allowing us to organize application types, services, URLs, and IP addresses for rules. For example, let's say we want to filter traffic using Layer 7 signature protocols. Initially, we create an application with details about that protocol and then add it to a list. This simplifies the process by grouping applications with similar rule actions. Similarly, if we need to control traffic based on Layer 4 inspection using signatures associated with specific port numbers, we create services and service list. For example, if we want to allow SSH and RDP traffic, we will set up two services, one for SSH on port 22 and another for RDP. These services are then added to a service list to apply rule actions. We can add both services in the same list as we want to apply similar action on both the services. So basically, you create applications and services and then add them to the list. This list will then be used as one of the criteria for your rule actions. Additionally, we can control traffic to a set of URLs using a URL list. For example, we might want to limit access to gaming and social media websites while allowing educational sites. In that case, we create a block list with all the gaming and social media URLs you want to block, followed by an allowed list for educational websites. The rule action can be configured using both lists to meet our requirements. We can use an IP address list to manage traffic to specific IP addresses or CIDR blocks, including both IPv4 and IPv6 addresses. After creating the list components, we move ahead to step 2. For creating decryption rules in a policy, you must first create mapped secrets and decryption profiles. Mapped secrets are stored in OCI Vault and are associated with inbound or outbound SSL keys or certificates. These secrets play an important role in decrypting and inspecting SSL or TLS traffic using methods such as SSL forward proxy or SSL inbound inspection. Decryption profiles, on the other hand, are like the managers that control how SSL forward proxy and SSL inbound inspection do their job. They decide how to monitor sessions, servers, and what to do if something goes wrong. For example, to prevent a man in the middle or replay attack, it will terminate the session if an expired certificate is encountered or the certificate issuer is untrusted. It will also block traffic if there is a timeout during the SSL handshake, as well as if an unsupported cipher version is detected. Now that we have got our lists, mapped secrets and decryption profiles ready, it's time to dive into the final step, that is creating rules. Rules are like the traffic police of our network. They decide what packets are allowed to pass and what gets stopped at the gate. First, we configure decryption rules as they are evaluated before security rules. With decryption rules, we define the source and destination IP addresses that need to match the packet information. Then, based on this information, the firewall takes action. It can either decrypt the traffic using an SSL forward proxy or SSL inspection, or it can decide not to decrypt at all. If decryption is selected, we must make sure to link it to the decryption profile and secret we set up earlier in step 2. Next, we have security rules. They decide which network traffic to allow and which to block. We use the lists we created in step 1, that is IP addresses, applications, and URLs, to define the match conditions for the traffic. Once we have a matching condition, we determine what action the firewall should take if the conditions are met. It will allow the traffic, drop it, or issue a reset notification. In addition, we can configure intrusion detection or prevention to log or block traffic as needed. Once our network firewall policy has been configured, it can be linked to one or more firewalls to put our rules into action. So to conclude, our policy defines how traffic flows through the network firewall using decryption and security rules. These rules are created using building blocks like lists, mapped secrets, and decryption profiles. Finally, the policy is linked to one or more firewalls to implement the security measures. So I hope you found this lesson useful. Thanks for your time. Hello and welcome back to the demo on OCI Network Firewall. In this demo, we will see how to set up and configure the OCI Network Firewall and the Network Firewall policies, and then look at the route rules that need to be configured to ensure traffic flows through our firewall. And we will divide this demo in 2 parts. In part 1, we will understand the use case and create our network firewall policy. And in part 2, we will deploy the network firewall, attach the policy to it, and then verify our complete setup. So let's get started. For this demo, we will look at the simple use case that will be deployed using the OCI network firewall. Consider we have 2 compute instances in a public subnet and a network firewall in a DMZ subnet that acts like a barrier between our cloud resources and the internet. It will filter the incoming and outgoing traffic based on the security rules you have configured in your network firewall policy to protect our resources from unauthorized access and various attacks. The table here shows the security rules that we want to add to limit access to our compute instances. Like we want to allow a particular internet host to SSH compute instance 1 and similarly allow only ping, that is ICMP, on compute instance 2. This simple setup is to understand the workflow. And in our second use case, we will see the URL filtering capability. So to deploy this use case, we will follow the step-by-step process, where I have already created a VCN, public subnet, DMZ subnet, and 2 compute instances. So our first step will be to create a network firewall policy with all the rules that required to limit SSH and ICMP. Then deploy the network firewall and attach the created policy. In step 3, we will configure the routing table as shown in the architecture diagram to ensure that all the incoming and outgoing traffic is routed through a network firewall. If you notice, the expanded capability of Internet Gateway allows you to attach routing table to it, which includes a rule that specifies a network firewall as the next hop for accessing subnets within the VCN. So before we proceed to the console, ensure that the following IAM policies are in place for configuring the network firewall in your working compartment or in your tenancy. And now I will switch to the OCI console. First, I will show you the pre-created resources. I have already created a VCN with the name Network Firewall VCN and two subnets. Public subnet for compute instances and Firewall DMZ subnet for our network firewall. Also, I have created two compute instances and they are in running state. Currently, the VM created here are in public subnet, but they can be in a private subnet as well. Now moving to our step 1 to create network firewall policy. For that, we navigate to Identity and Security and click Network Firewall Policies under Firewalls. Here we will create the network firewall policy with the name Network Firewall Policy 01 and select our working compartment and click Create. An empty network firewall policy will be created. Now for creating rules, we will first start creating the required components. First, to allow ICMP, we need to create the ICMP application. Go to Application, Create Application, and currently it supports only ICMP at layer 7 and other layer 7 applications are work in progress. Name the application ICMP for VM02. Select the protocol ICMP, type 8 and code 0 so that we can ping. Click Create Application and then we will create an application list to combine the application that have the same security settings. We will name it as Application List 01 for VM2. Select our ICMP application for now and add it to the list. Create list. And similarly, you can create application and application lists for layer 7 protocols for signature based filtering. Then to allow SSH into VM01, we will create service for SSH. We create services for matching applications of layer 3 and layer 4 protocols and ports. Click Create Service, provide the name SSH VM01, select the TCP protocol and the port number will be 22. Create service and then again we create service list to add one or more services to allow or deny traffic to a single service or collection of services. Create a service list list 01 for VM01 and add our SSH service. Click Create Service List and we have created our list. Next, the URL list. We will see this in the next demo where we have a use case on URL filtering. Then we need to create IP address list. We will create 3 IP address list. One for the IP address of the internet host from where we want to allow connection to our compute instances for SSH or ICMP. Here I will enter the name as internet host IP address and enter the public IP address of my local machine. Click Create and now we will create another IP address list for VM01 and VM02 including their private IP addresses. First I will get the private IP address of both the VMs and then add them to the list. Similarly for VM02. And now we have created all the required components. We can also configure map secret and decryption profile if our policy requires setting up decryption rules. That requires certificate authentication so that we can decrypt SSL or TLS traffic for inspection. For now, SSL or TLS inspection is not in the scope of this demo, so we will skip this component and move ahead. Now we will go ahead and create our security rules. The first rule that we will be adding is allowing the SSH from internet host to VM01. So I will call it as allow SSH for VM01, and then we will set up a matching condition. The source IP will be the internet host IP list that contains the public IP address of internet host. The destination will be our VM01 that contains private IP address of VM01. Now we do not want to allow ICMP to VM01, so we will keep it as any application and move ahead with service list. Here we will select the SSH service that we have created. Next, URL can be any URL for now, and then the action will be allow traffic, and this will be the first rule. Click create rule, and similarly we will create a rule for denying ping from internet host to VM01. For that, click add security rule. I will call it as deny ICMP on VM01. Select the matching condition from the internet host to VM01. Now the application will be ICMP. Select our ICMP application. From any service and from any URL, the rule action will be drop traffic. Save changes. The second rule has been added. Now this rule will limit pinging to VM01. Now we will create a rule to allow ICMP on VM02. Name the rule as allow ICMP for VM02. For matching condition, again select our internet host IP list, and the destination will be our VM02 IP list. This time the application will be our ICMP application. Again, we do not need to add any service, and the URL can be any URL. The rule action here will be allow traffic, and we add the rule. Now we have all the security rules added as per our setup. Next, we will deploy our network firewall and attach this policy. We will continue our demo in part 2, where we will see how to deploy network firewall and then verify our setup. Hello everyone, and welcome back to the demo on OCI Network Firewall. In this demo, we will look at the second use case, where we will explore the URL filtering capability of OCI Network Firewall. For this demo, we will refer the same setup we had in the previous demo. But now, if you look at the rules table, we have additional rules to show the URL filtering capability, where we will block the access to one of the social media website, suppose facebook.com from compute instance 1 and to yahoo.com from compute instance 2. Also, it is important to note that since we are opting to deny specific traffic, we need to allow access to other websites at the end, and the order of the rules matters. And if you do not add this particular rule, the network firewall will by default deny everything at the end if no rules are matched. The deployment steps will remain the same. First, we create the network firewall policy, but this time we will not create a new policy, but we will clone and edit the existing policy, and then attach that updated policy to our network firewall. All our routing configurations have already been performed, so we will skip this particular step. So now let's go to the console, and first we will navigate to our network firewall policy. Here we will edit the network firewall policy 1 by cloning the policy. Once the clone copy is ready, we can edit the policy. Now for this use case, we need to block certain URLs or access to certain websites. For that, we need to allow or deny access to protocols like HTTP and HTTPS on port ATN443. 3. So to allow and deny ports on layer 4, we need to create service. Click create service and we will create the first service for HTTP protocol. Name it as HTTP service, TCP protocol and port 80. And then we will create one more service for port 443. Service name will be HTTPS service, TCP protocol, port 443. Now both the services are ready. We will add them to service list so that we can apply same actions for both services. Click create service list, provide the name HTTP and HTTPS service list, select both the services and add to selected, and then create the service list. Your service list will be created with 2 services. Now we will create the URL list and add the websites we need to block from VM1 and VM2. First, for VM1, click create URL list, provide the name VM1 blocked websites, and then enter the website URL that you want to block, www.facebook.com, and on the next line I will use the wildcard *facebook.com to block all subdomains. Create URL list, and now we will create another URL list for VM2. Name will be VM2 blocked websites, and website URL www.yahoo.com, and same *yahoo.com for subdomains. Now both the URL lists are ready. Next, we will not add any IP address as we already have the IP address list created for internet host and for both VMs. So we will go ahead and configure the rules to block access to the websites from VM1 and VM2. Click create rule, provide the name block URL VM1. Source will be our IP address list of VM1. The destination can be any IP address. Keep any application and select the service we created for HTTP and HTTPS. Next, under URL, select the VM1 blocked website list that contains the website that we want to block from VM1. From action, select drop traffic. This rule will block access to facebook.com from VM1. Similarly, we will add one more rule for VM2. Create rule, provide the name, block URL VM2. Source will be our VM2 list, and any destination, any application, and again select our HTTP and HTTPS service list. And under URL, select the blocked website list for VM2. Action will be drop traffic and then add our rule. Since we have denied specific URL traffic, we must allow access to other websites from VM1 and VM2. If you do not add this particular rule at the end, the network firewall will by default deny everything if no rules are found. That means our VMs will not be able to access any websites. So we add new rule to allow access to other websites. And this will be a common rule for VM1 and VM2. So I will select both the list in the source. Destination can be anything, any application, and then we will include our HTTP and HTTPS service list. This will only allow HTTP or HTTPS traffic, and no other services will be permitted. Now the URL can be any URL, and the action will be allow traffic. Most importantly, the rule should come after what we have denied, as we know the order of the rule is important. Now our policy is ready with the updated rules. We will attach it to the network firewall. Edit and select our clone copy or updated copy. It will take few minutes to update the network firewall, and then we can test our URL filtering configuration. Our network firewall is active. I go to my terminal on the local machine and SSH into VM1. And now I am going to use the curl command to access the blocked website first. And as you can see, we are not getting any response. And now if I try it for any other website, I will test it for Wikipedia, and you can see we got the response. Similarly, you can verify this on VM2. Also, you can go to traffic logs and see which rules are applied for allowing and denying our traffic. This indicates that network firewall is successfully blocking the website entered in our blocked URL list. So to wrap up, now you know how to utilize network firewall's URL filtering capability and to control access to websites. The same use case can be implemented for the updates of your operating system or applications from the trusted canonical websites. So I hope this was helpful. Thanks for your time. Welcome back, and we are going to continue to deploy the OCI network firewall. Navigate to the network firewall and click Create Network Firewall. First, I will provide the name Network Firewall 1. Select our working compartment and then attach the policy that we created, that is Network Firewall Policy 1. Then we need to select the enforcement point, that is our DMZ subnet. Select the VCN, select our DMZ subnet and click Create Network Firewall. The network firewall will take approximately 15 to 20 minutes for setup and be in an active state. However, within few seconds, you will get the private IP address of network firewall. We require that IP address for configuring routing tables. We will keep the work request running and go ahead to configure the routing tables to route traffic through the network firewall. We will go to our network firewall VCN and configure an internet gateway so that we can access the internet. I will name it Internet Gateway 1 and click Create. Then we go to the routing table and create 3 route tables based on the architecture diagram. The first route table, which includes a rule that allows traffic to any IP address on the VM subnet, should pass through network firewall's private IP address. Click Create Route Table, provide name VM to network firewall in our demo compartment, and we will add a route rule for the private IP address. Our destination will be any IP address 0.0.0.0 and the target will be a network firewall IP address. It will provide details of the network firewall to verify the mapped IP address. I will add a description for our understanding, route table for VM to network firewall traffic. Click Create. Now we will attach this to the VM subnet. For that, go to Subnet, VM Public Subnet and click Edit. Select the route table VM to network firewall for this subnet. Now all traffic from this subnet will be forwarded to the network firewall. Next, we will configure the route table for firewall subnet as we want all the traffic to be navigated to Internet Gateway for internet access. So, create route table, provide name, network firewall to Internet Gateway and add rule for Internet Gateway. Destination we will set as any IP address and select target Internet Gateway and add description route table for network firewall to Internet Gateway. Now we need to attach this to firewall subnet. Go to subnet, edit and select our route table. The last route table is to pass traffic from internet to our VCN through network firewall. We call it as route table from Internet Gateway to network firewall 1. Add a rule by selecting a target type as private IP. Destination will be the CIDR block of VCN, that is 10.0.0.0/16. Anything coming to the VCN from the Internet Gateway will first go to the network firewall, so add IP address of network firewall. Route table for Internet Gateway to network firewall. Click Create. And now we will associate this routing table with the Internet Gateway. Now our route table is associated with the Internet Gateway. We have now completed the routing configuration. Also, ensure that the security list or network security groups you are using allow network traffic to flow as they are evaluated before the network firewall. Now before we can verify our setup, we need to ensure that our network firewall is active. You can see our network firewall is active and the whole configuration is ready. We can test or verify the setup. And to verify, I go to the terminal of the internet host, that is my local machine. I will start by testing SSH on VM1. For that I need the IP address. Go to the compute instance and get the public IP address of VM1. Copy the public IP address and we will hit the SSH command. And here we have a session that indicates that the firewall is passing SSH application traffic from the internet host to VM1. You can enable traffic logs for the network firewall in order to verify the rules applied. Next we will test the ICMP. So I will ping to VM01 and you can see I am not getting any response. That means the traffic is denied. Now I will try to ping VM02. First I will get the public IP address of VM02 and then hit the ping command. And you can see we got the response. Now this indicates that ICMP packets are allowed only on VM02. You can see the rules applied. Go to traffic logs and check the log data. Here you will get all the data about allowed packets, denied packets or default denied packets. So to wrap up, we have taken a use case or a scenario to allow and deny certain applications. For that we created a network firewall policy and added the required security rules. Then we created a network firewall and attached the policy to it. Also, we configured routing tables to ensure traffic flows through the network firewall. And at the end, we tested and verified the setup. I hope this was helpful. Thanks for your time and happy learning.